Technology. Paul, how does static electricity work? Well, it's an imbalance between negative and positive charges in objects. But what does this mean? You have probably experienced it yourself when you pulled off a woolen sweater and the hairs on your arms stood up. Well, that's electrostatic energy. In practice, this could be bad, like when touching electronic parts or even people. But even without a woolen sweater, there's always a chance static electricity could build up. However, Bekaert has a practical solution for these problems. Just watch these examples. Paul is inspecting a gas plant. With each step he takes, he becomes more and more charged due to the rubbing of his arms with his clothing. Charged Paul touches a gas tap, and he feels a spark. Paul has to repair a gas leakage. He walks through the gas plant, and with each step he takes, he becomes more and more charged. The charges are coming from his feet and from above, due to the rubbing of his arms with his clothing. Charged Paul approaches the gas pipe, which has a gas leakage, and touches the pipe. Paul is heading over to a production unit. He comes in the proximity of a charged big bag, and the charges are attracted to Paul's clothing by induction. Charged Paul approaches a metal gas pipe, which has a gas leakage, and touches the pipe.
The facility was a wholesale distributor of solvents and other industrial chemicals, which were stored in large outdoor tanks. About 8:30 on the morning of the accident, a tanker trailer arrived to transfer a non-conductive solvent known as varnish makers and painters, or VM&P naphtha, into a storage tank. Because liquid flowing through pipes and valves generates static electricity, which can ignite flammable vapor, the tank farm supervisor connected a cable between the truck and an electrical grounding station. In addition, all the equipment involved in transferring the liquid was bonded, that is, connected together with electrical conductors and grounded. Inside the 15,000-gallon storage tank, there was a device for measuring the liquid level. A metal tape, which was grounded, was suspended from pulleys and connected to a metal float by a loose, flexible linkage assembly. This linkage presented a hidden danger during the filling of the tank. The solvent was pumped from 3 tanker trailer compartments into the tank. As the hose was switched from one compartment to another, air entered the line, creating bubbles and turbulence inside the tank. A static electrical charge built up in the non-conductive liquid. Meanwhile, the space above the liquid was filled with an explosive mixture of vapor and air. The swirling, turbulent liquid caused the float to drift and rock, creating slack in the metal tape. This allowed a gap to form intermittently in the linkage assembly, interrupting the grounding of the float. The metal float accumulated a static electrical charge. About 9 a.m., a spark from static electricity ignited the vapor-air mixture, causing a massive explosion. The blast sent the storage tank rocketing into the air. 2 more tanks quickly ruptured and released their contents into the rapidly expanding fire. As the fire raged inside the tank farm, other tanks burst and ignited, launching heavy steel tank lids 10 to 12 feet in diameter into the air. 20,000 gallons of flammable liquid were released into the spill containment area. Valves, pipes, and other heavy steel objects were hurled off-site and into the adjoining community.